Hey guys, so I have a last example to show you guys about calculating the area in section 14.3. So question number 13 is asking us to evaluate this integral where r is bounded by these two circles, x squared plus y squared is equal to 1 and x squared plus y squared is equal to 2. So the first step that we need to do is to get our limits of integration. So we can do that by drawing the two circuits and then see what the question is asking. So a circle that has a radius of 1, just say that this is 1, 1, and 1. And a circle with the radius of square root of 2. So we can say just to scale. So it's just going to be square root of 2 here, square root of 2 here, and square root of 2. So we're interested in this region. That's outside of the smaller circle and on the inside of the bigger circle. So you can see that our limits of integration for theta is just 0 to 2 pi. Yeah, and our limits of integration for r, meaning how much length do we have, is just going from 1 to square root of 2. So we can go ahead and set up our integral. So we can say that theta is going from 0 to 2 pi, and r is going from 1 to square root of 2. And then we can sub in the values here. So we have y squared over x squared plus y squared over dA. Then we can go ahead and sub in the values for y and x. So we have 0 to 2 pi again. R squared sine theta. Then x squared plus y squared is just equal to r squared. And then we have dA is equal to r dr d theta. So these two cancel each other out. We only have r d theta. So what we can do is just solve for 0.2 pi. So we're solving for this integration. dr d theta. So the first and the last example. So I had the integration giving me this expression. So once you simplify it, you have 0 to 2 pi sine squared theta d theta. Then you have the 1/2 on the outside. So you can solve this using the trig identity, which gives you the integration of 0 to 2 pi so what I did there is that I used this trig identity, which is basically 1 minus cos 2 theta over 2, but I took the 1/2 outside. So you can solve this from 0 to 2 pi, which is going to give you 1 over 4 theta minus 1/2 sine 2 theta, evaluated from 2 pi to 0. And if you sub in these values, it's going to give you pi over 2.